For today's notes, you will need IC64. This is part 1 of Standard 15, where we are going to learn about surface area of 3D solids. There is some introductory material for our notes today because we're starting a new standard, so we need to kind of set the stage about, as well as specifically look at the idea of how it works in right prisms. So let's go ahead and get started with some important vocabulary and abbreviations. Surface area is abbreviated as capital S, capital A. And so what we find when we're talking about surface area is the total area of all surfaces of a geometric solid. And so specifically, we will talk about lots of different kinds of solids as part of Standard 15, but our solid for today is a prism. And in order to find the surface area for a prism, we're going to end up taking P times capital H and then adding in 2 capital B's. Well, that's an awful lot of letters, and some of them are familiar, but they're capitalized instead of being lowercase. So we're going to take some time to make sure we understand what each of those abbreviations stand for. P should be familiar to us from our AP/2 formula that we use during Standard 14 for regular polygons. It is going to stand for perimeter again. But because we're dealing with a solid that's 3-dimensional, you can see some of them at the bottom of the screen right now, we need to be specific about what we're finding the perimeter of. So the perimeter needs to be of whatever is considered the base of the geometric solid. Capital H is going to be a height, like lowercase h was in Standard 14, but the height has to be of the entire geometric solid, which means it's really describing the distance between the bases of the solid. And then capital B represents the area of the base of the geometric solid. And because we're dealing with right prisms today, the bases are always going to be parallel to one another, and they're going to be congruent, and they're going to be connected to one another by rectangular faces, so by rectangles. Okay, so because there's a lot of vocabulary and because identifying the vocabulary is so important, we're going to spend the first part of our notes today really focusing on identifying these key features in the prisms. So for each prism below, we're going to shade a face that could be used as the base. That's our first thing. I'm going to do that in yellow. Then we're going to highlight and label a distance that represents the height. I'm going to do that in green, and this is going to be the capital H height that we were talking about. And we're going to talk about giving the prism a name based on its features. So let's go ahead and start. If we're looking at this first prism, we need the base, remember, to be the sides or the faces of the prism that are parallel and also congruent and connected to one another by rectangles. So a lot of times we look at the bottom or the top of the shape to see if it could be a base. Does the bottom seem parallel and congruent to the top, and is it connected, or are they connected to one another by rectangles? And the answer is yes. So we could shade the top of this and call it a base, and we could shade the bottom of this and call it a base. If we do that, if we make that choice, then that capital H height is going to be what connects those bases together. So we could label it right there, connecting those back corners together. We could label it right here, or we could label it over there, or in the back we could label it. Lots of different options, but all of those distances would be the same because we've got this parallel congruent base situation happening. Now, when we look at this base, it definitely looks slanted like a parallelogram, but the reason that that happens is because these are drawn with perspective so that your brain gets tricked into seeing them as 3-dimensional, even though they're all on a flat piece of paper. And so what happens when we have something that looks like this is that it's actually representing something rectangular, It might be representing something square, but we don't know that because we don't have measurements showing us that these match. But what we do know is that it's going to be rectangular. So we could imagine right angles in the corners of the base. And then it's going to be a prism because it fits the characteristics of a prism. Two congruent parallel bases connected by rectangles all the way around. This looks a little bit messy, but that's just a right angle box. Okay, so when we move to the next one, we're looking for the same thing. We're looking for a face that could be used as the base. So when we're looking at the bottom and the top this time, they look different than before, but are they parallel and congruent, and are they connected to one another by rectangular surfaces? And the answer is yes. So we're going to be consistent, and we're going to use the bottom of this prism. That will be shaded as a base. And the top could be considered the base, which means, again, our height, our capital H height, the distance between the bases, could be any of these segments that connects corner to corner from the top face that's the base and the bottom face that's the base. Now this time, those bases have a triangular shape, so when we're naming our prism, we're going to call it a triangular prism. All right, moving on to question number 3 and 4. We're going to work on the same thing. Looks like that got a little bit blurry, so let me make sure you can see here. Okay, if I'm investigating number 3 and I'm looking at the bottom to try to identify the base, I'm not seeing a surface there. And in fact, I just see a segment at the very bottom of that. This looks kind of close to the bottom, but that seems rectangular to me, and so does this front face right here. What seems different than the rectangles would be over here on the left, which matches, is congruent to, and parallel to what's over here on the right. So this time, our prism is kind of tipped up on its edge, and those bases are on the left and right-hand side instead of on the top and the bottom like they were in the previous 2 examples. That also means that our height, instead of traveling vertically, is going to travel horizontally. So our height's going to be back and forth in between those 2 left and right bases. Now, if I look at what's happening here, this base has 1, 2, 3, 4, 5, 6 sides. So from my standard 14 work, I know that's a hexagon. So this is going to be a hexagonal or a hexagonal prism. So we name our prisms based on thinking about the shape of the base and then saying that it's a prism. All right, last but not least, we have our 5-sided shapes here, it looks like, that are connected by rectangles. So we've got that one, which could count as a base, and then also this one here, which would be the second base that's parallel and congruent, which means our height is going to be one of these connecting distances vertically again in the picture. It looks like we've got 5 sides this time around that base shape, so that would be a pentagonal or pentagonal prism. Okay. So a couple more things for us to think back to the past on, and then we'll see how we can put this all together to find surface area. Capital B is going to be related to the base that we shaded in. And so in this first problem, we saw that the base could have a rectangular shape. So if we're going to find the base area, the capital B part of the formula for surface area, we're going to have to go back in our memory banks to standard 14, where we had these formulas right here, and remember which one of these was for rectangles. That should be lowercase bh. So there is a definite difference between a lowercase b and a capital B. Remember, lowercase b would have been any side of the rectangle, and then lowercase h would have been the side of the rectangle that forms a right angle with the one that you chose for the base. So if we come back up here to our first rectangular prism, capital H is in between the bases, but lowercase b and lowercase h would be flat on that bottom or up here on the top part, connected to the base of the shape only, not describing the distance between the bases. Thinking about triangles, back when we were finding area of triangles, we use lowercase b, lowercase h divided by 2, which if there was a right angle in a triangle meant that we could use 2 of the sides. So it might look like that with the base and the height. Or if there was not a right angle visible, then we often drew our height in through the middle. And so if we pop back up here to number 2, it's not super clear whether we have a right angle or not. But if we knew that this was a right angle, so I'm going to add that onto the diagram, then we could use this edge right here as our lowercase b and this edge right here as our lowercase h. Otherwise, we would have to do more work to figure out where that height is at if that right angle was not given to us. All right, and one more. If our base is a regular polygon, which is what we have going on in these two situations, then that capital B formula is going to be AP over 2. Remember that A was the apothem value that was perpendicular and intersected that side at the midpoint. And then the P, grab a different color, was the perimeter all the way around that shape. Okay? So if we're looking at these prisms that have regular polygons as faces, we would have an apothem that's laying flat on the bottom or flat on the top of that shape, and then we would have this distance all the way around the shape that would be the perimeter. So we would just be focusing on features for the bottom to find that capital B or features from the top to find that capital B. Over in number 3, that's going to look a little bit weird because the bases are on the left and the right. But again, the apothem would start in the middle and travel out to the middle of the side. And then that perimeter would be the distance around that base. So not necessarily at the bottom of the shape this time since it's tipped up on its edge, but around whatever that face is that's acting as the base.